In this problem, AB, CD, and EF are parallel chords on the same side of the center of a circle. The distance between AB and CD is equal to the distance between CD and EF. AB is 20, CD is 16, EF is 8. The radius can be expressed as k squared of w over p, so we want to determine the sum of k plus w plus p. Okay, so r is our unknown. So in this circle, we've got our center, and first we have the chord AB. That's the big one. Now, I can draw my radius out to here, and if I draw perpendicular like that, that's going to cut this chord in half. Because the one thing the radius always does is when you draw a perpendicular radius to the chords, it always cuts them in half, and I'm going to use that in this problem. So, that means that this length right here, if AB is 20, this length is 10. And so now, this right here is the distance from chord AB to the center. And we can find that using the Pythagorean Theorem, which is square root of r squared minus 100. All right, I'm going to draw another picture. This time, arc CD. A little bit further away. So r is still our unknown. This time the perpendicular cuts it in half, and so now this length is 8. So we have square root of r squared minus 64. This is the distance from the center to CD. And then finally, draw another circle. And so here we now have arc EF. There we go, EF. So we have R. Now EF has a length of 8, so we cut that in half, that's 4. So we have square root of r squared minus 16. That's the distance from the center to EF. All right. Now what it said in the problem is that these chords are equally distanced apart, which means, how do we express that? The way we express that is we say, all right, to get the distance between AB and CD, we're going to subtract these two quantities. We're going to say square root of r squared minus 64 minus the square root of r squared minus 100. That's going to be equal to the difference in these distances. So we've got square root of r squared minus 16 minus the square root of r squared minus 64. And so what we have to do now is we have to solve for r. So what I'm going to do is we have two quantities with r squared minus 64. So I'm going to get those on the same side. So I'm going to add this over. So it's going to be 2 square root of r squared minus 64. And I'm going to add this quantity over to the other side. So this is square root of r squared plus minus 16, they're all minus, plus square root of r squared minus 100. Okay, so to work on getting rid of these radicals, what I'm going to do is we're going to square the whole equation. Now the left side's pretty straightforward. We square 2, we get 4. We square this, the radical goes away. R squared minus 64. The right side requires a little more work, because what this is we've got a plus b squared. This is squaring a binomial sum. So this would be a squared plus 2ab plus b squared, where this is a and that's b. So if I square this, that's fine. We're just going to get r squared minus 16 plus 2. And then we have to multiply this times this. Now I'm going to multiply them under the same radical, since it's both square roots. R squared minus 16, r squared minus 100. And then plus b squared. So this is b, so if we square it, we get r squared minus 100. Okay. So now, what we have to do is we're going to combine like terms. So we've got 4r squared minus 256. We've got an r squared and an r squared here, so that's 2r squared. We have minus 16 and minus 100, so that's minus 116. 2 square root of r squared minus 16, r squared minus 100. All right, everything can be divided by 2. So let's just make our numbers just a little bit simpler. So we'll divide the entire equation by 2. So 2r squared minus, that's going to be 128 equals r squared minus, that should be 58, plus square root of r squared minus 16, r squared minus 100. All right. Now, we just have one radical, but we're going to have to square this equation again. But first, we're going to get these on the other side. So if I subtract r squared over, we get r squared. If I add 58 over, then we get minus 70 equals square root of r squared minus 16 and r squared minus 100. Okay. So now that this radical is by itself, we'll square both sides. So when we do that, now this one, we're going to have to treat that like a difference quantity, like a minus b quantity squared. So that's going to be a squared minus 2ab plus b squared. So if I square a, which is r squared, that's going to be r to the 4th, minus 2ab minus 2 times negative 70. So that's going to be minus 140 r squared, plus that squared is going to be 4900. And then the radical comes away here, so we've got r squared minus 16 and r squared minus 100. So we need to expand this out. So when we expand this out, we're going to have r to the 4th minus 116 r squared plus 1600. Now both sides have an r squared, so we can cancel them away. That's nice. So negative 140 r squared plus 4900 equals negative 116 r squared plus 1600. So we want to get r squareds on one side. So I'm going to add 140 r squared to both sides. And I'm going to subtract 1600 from both sides. So we have 3300 equals, that's going to be positive 24 r squared. So when we divide by 24, let's see what we get. 3300 divided by 24 gives us 137.5, or 275 halves equals r squared. Now we want the exact value because we're going to have to take the square root. So let's see. Square root of 275 and 2. Well, neither of those are perfect squares. But 275, let's see. How can we break that up? 275. Let's see. Can we take out 25? I bet we can. 275 divided by 25 is 11. There we go. So we have 5 square root of 11 over square root of 2. Now it's not going to be 5 plus 11 plus 2 because the way the problem said it has to be k radical w over p. So this problem wants our answer in rationalized form. So we have to multiply square root of 2 over square root of 2. So that means we get 5 radical 22 all over 2. So that's k, that's w, that's p. So they want the sum. So it's 5 plus 22 plus 2, which is 29. And there's our answer. And we're done.